Hey guys, this video is on ionic compound formation from aqueous ions. There are a number of ways that ionic compounds can form, and one of those ways is if ions are floating in water of opposite charge. They can combine to form what are called ionic compounds. An example of this would be silver. Now, silver has a charge of +1 when it's ionized. And silver floating around in water, and we know that it's floating around in water because it's designated here as AQ, as aqueous. If it's floating around in water, silver can combine with another ion, such as chloride, to form a compound. The positive silver is attracted to the negative chloride. And when those two smack together, sometimes they stick. And when they stick together, you have what's called silver chloride. Ag positive, Cl negative have opposite charges. As you know, opposites attract. What compound they formed is dictated by how positive and how negative each of these ions are. Notice that the chloride is -1 and the silver is +1. And these two come together in a 1-to-1 ratio to form silver chloride AgCl because the +1 and the -1 sum to 0. In this case, it's a simple 1-to-1 ratio and we get a solid product, AgCl, which precipitates out of solution. I'm going to erase those charges. Even though those charges are there, scientists don't show them. It's understood that if you have a metal and a non-metal together, silver being the metal, chloride being the non-metal, when these two are together in a compound, you have an ionic compound. It's ionic because it is made of ions. That's what's causing the silver and the chloride to stick together and to form something that is what's called a solid precipitate. Let's try another example. Calcium. When calcium, floating in water, comes in contact with what's known as the carbonate ion, also floating in water, aqueous, you get an insoluble compound or an insoluble precipitate. That insoluble precipitate, CaCO3, is designated as S, meaning it's solid. Here again, we have a ratio in which the positive and the negative charges balance to 0. 2 plus and 2 minus sum to 0. So when we make a solid compound, calcium and carbonate also come together in a 1-to-1 ratio to make CaCO3. This, in fact, is how coral reefs, shells, chalk, these are all examples of calcium carbonate, how they form. Let's take another example which is a little less straightforward. Sodium, Na+, aqueous ion. That's the form that's floating around inside your body, Na+. When sodium comes in contact with the oxide ion, it can form a solid precipitate. NaO, we stick them together. However, we're not quite done with this example. Unlike before, where we simply just put Ag and Cl together to form AgCl, or Ca and CO3 together to form CaCO3, in both of these cases, what we saw was, the positive 1 was balanced by the negative 1. The positive 2 was balanced by the negative 2. However, in our example below, the +1 of sodium is not completely balanced by the O2-. Instead, we have an imbalance here, and we have too many negatives. If the oxide is 2- and the sodium is +1, the ratio in which these two come together is dictated by the need to form a neutral compound. This is how nature acts. If just one sodium smacks against the oxide ion, it's still -1. And so therefore, the oxide attracts yet another sodium. The compound that does form in the end is Na2O. This way, each sodium, which is +1, now gives a total of 2 positive to balance the 2 negative of the oxide. What we get is Na2O. Again, even though the compound is in fact ions, made of ions, we don't show those charges. Let's try again. How about something even more difficult? Aqueous iron, one form that it takes is the 3 positive ion. If it comes in contact with S2 negative, the sulfide ion, a compound forms that is not as straightforward as a 1-to-1 ratio. Notice here that the iron is 3+, and the sulfur, or the sulfide, I should say, is -2. Simply putting these two compounds together in the ratio of FeS will not represent what nature forms. Instead, what nature does is it creates a compound whose overall charge is 0. Because we can't turn -2 into a 2 into a 3 with simple multiples, we need to find the least common multiple of 3 and 2. In this case, if the iron is 3 positive and the sulfide is 2 negative, the only way to find the least common multiple, the only way to get the correct ratio is to find the least common multiple of 2 and 3, which is 6. So therefore, 2 times 3 positive gives us a total of 6 positive for the irons, and 3 times 2 negative gives us a total of 6 negative for the sulfides. Of course, we must balance on this side of the equation. 2 iron ions come together with 3 sulfide ions to give us Fe2S3. Again, we don't show our charges in our compound. One final example. If we have magnesium, Mg, 2+, aqueous ion, and we have NO3 -1. If these two form a compound, an ionic compound, the ratio is not going to be 1-to-1. Notice that with magnesium's 2+ and nitrates -1, the simple 1-to-1 ratio will not sum our charges to 0. How many nitrates do we need? Yep, we need 2 nitrates. And when we make this compound, we need to keep one thing in mind. Because the nitrate is NO3 already, we need to add parentheses around the nitrate before we add the 2. If we simply added that 2 without the parentheses, it might look like NO32, right? We don't want that to happen. So what we do is we add the parentheses, gotta add that 3 back first, and then put the 2. And what this means is the 2 distributes, right, only to the N and the O, not to the magnesium. So we have magnesium with its 2 positive charge and nitrate with its -1. 2 times -1 for the nitrate is -2 to balance the magnesium's +2. And this is how you make ionic compounds from aqueous ions. Just to review, when silver and chloride come together, because it's +1 and -1, a simple 1-to-1 ratio, AgCl, works just fine. Because calcium and carbonate, CO3 2-, come together, 2+ and 2- sum to 0, CaCO3 ratio 1-to-1 ratio, just fine. We get a little more complex with sodium and oxygen, iron and sulfur. In these cases, it's not a simple 1-to-1 ratio. Nature doesn't follow those rules. In order to create compounds that have overall charges of 0, we need to take several of the sulfide, for example, 3, and 2 of the iron in order to get an overall compound whose charges sum to 0. Lastly, with magnesium and nitrate, the only additional level of complication here is going to be these parentheses. When you have something that has a subscript on it like nitrate, you must add the parentheses when you are counting those. Because if you don't, without parentheses, something like FeSO4, let's say if the iron is 3 positive and the sulfate is 2 negative, the compound that forms between iron and sulfate, if we simply put a 3 here and a 2 here, the iron clearly is just fine, but the sulfate looks like SO43. To avoid that problem, we add parentheses, letting us know that it's the SO4 as a group that's taken 3 times. That's how you form ionic compounds from aqueous ions.